All right, so let's go through the first part of the proof for the exchange lemma. And this is, remember, we have to show two things. We have to show that b hat is linearly independent, and we also have to show that the span of b hat is the same as the span of b, the basis b. Okay, so let's go through the first part, which is on linear independence. Okay, so we'll call our outcome of the exchange b hat. Okay, that's going to be after the exchange. The new sequence is going to be b hat. Okay, so now we have to show that b hat is a basis. Okay, so here's our sequence, right? So there's v, there's the exchange for b sub I, right? So we exchanged v for b sub I. Okay, so first we're going to show that b hat is linearly independent. So any relationship d1 beta sub 1 all the way to d sub I v, right? All the way to d sub n times beta sub n equals the zero vector among the members of beta hat after substituting for v, right? Oh, excuse me, hold on. Let me start. Yeah, so any relationship here among the members of beta hat, right? And now after substituting for v, what do we get? Well, all we're going to do is substitute. So keep in mind, so let's just, bears repeating here. So any relationship of these equals the zero matrix among the members of beta hat. Okay? After substituting in for v, we get this. So all we're doing is we're taking v and we're substituting for what v is. Remember, v is a linear combination of the betas from the basis b, right? So this linear combination here, it also includes b sub I. Okay, I didn't get the chance to write it in here because of space, but we're putting in this piece in place of vector v. So now all we've done is rewritten that equation, right? So here it is. Okay. Now, this gives a linear relationship now among the betas of the members, among the members of B, right? So these are all the betas. So this goes beta 1 through beta sub n. Okay? So now, we know, by definition, because we know P is a basis, that it is linearly independent. So the coefficients are the coefficient, right? So now, let's go back here. We're distributing the d sub I, right? And so all of these coefficients here are going to be d sub I times C1, d sub I all the way through here. But remember, there's a c sub I, beta sub I in here, right? So we're going to get a d sub I times c sub I as a coefficient on that beta sub I term. So, back down here, that d sub I, c sub I coefficient of beta sub I is 0. Why? Because it's a linear combination of the betas from the bases. So, but we assumed, right? Our assumption is that c sub I is not 0. So that means d sub I must be 0. Now, if we take that if we use that up here, right, if we go back here and use that, we find that all the d sub i's, all the d's, all the coefficient d's are 0. And so therefore, beta hat is linearly independent. And that finishes the first part. Now, in the next part, we now have to show that the span of B hat is the same as the span of B. All right.